All right, so what we're looking at today is runoff and stream discharge. Runoff and stream discharge. All right, so remember various parts of the water cycle. Precipitation, basically when it rains. When the rain hits the ground, a few things could happen. Some of the water will evaporate back up, some of the water will soak in the ground, and yet other water will flow across the surface, which is runoff, which is what we're looking at today. So questions asked, when does runoff happen? All right. So runoff occurs when, one, rate of precipitation exceeds infiltration rate. All right. So basically what that means is it's raining faster than the ground can take it in. And I could do a little demonstration over here. All right. So here we got a sponge. All right. And let's say that it was an all-day drizzle. All right. So it's raining and all day there's a drizzle. And I'm going to pour about 100 milliliters of water onto the sponge. So the sponge represents the ground, and this is going to represent how much rain fell. All right. So an all-day drizzle is when the rain's going to be like a slow rain all day long. All right. And what you'll notice is when I slowly pour the water into the sponge, or it slowly rains outside over a long period of time, is that the sponge or the ground is able to take in most of the water. All right. That's what happens when there's like a mild or a slight rain. All right. Now, same amount of water. But instead of pouring it slowly on the sponge, I'm going to pour it more quickly onto the sponge. So that would represent like a type of rain that you'd get with a thunderstorm. So with a thunderstorm, it's a very heavy rain usually for a shorter amount of time. All right. So same amount of water, I pour it on the sponge much faster, and you can see that much more of the water ran off the surface because I was pouring it faster than the sponge could take it in, therefore allowed it ran off. Same thing holds true in nature. If it's raining faster than the ground can take it in, then you're going to get lots of runoff. All right, 2. Runoff occurs when the ground is saturated. So what saturated means is that the ground is filled up. All right, and I could demonstrate that again using that same sponge. All right, same amount of water. So right now I'm squeezing the sponge out. So the sponge is relatively dry. So when I pour the water on the sponge, there's places for the water to go. All right, there's places for the water to go. All right. And as a result, the water goes there. All right. So when there was a lot of empty space in the sponge, again, the sponge took the water in. All right. Now, what I'm going to do now is take the sponge and put it in this container of water. All right. All right, so the sponge has been in a container of water, so the sponge is saturated now. It's completely filled with water. So now when I try to add water to the sponge, the water's not going in it because there's no place for the water to go. The ground's already saturated. All right, the sponge is already filled up with water. So there's no place left for the water to go. All right. So the same thing happens in nature. All right. So let's say it was, if it was raining on Monday, Tuesday, Wednesday, Thursday, and then it rained a little bit on Friday, well, the ground's probably saturated from the first few days. So on Friday, when it rained, there's probably no place for that rain to go. So it's probably mostly going to be runoff. Whereas if it was dry on Monday, Tuesday, Wednesday, Thursday, and then I got that same amount of rain on Friday, a lot more of that water would soak in the ground because the ground's probably not saturated at that point. Okay. All right, runoff occurs when 3, slope the ground's too great for infiltration. And guess what? I could demonstrate that with a sponge as well. All right, same sponge, same amount of water. If I pour the water on the sponge when it is flat, what you're going to notice is that by and large, most of that water is going right into the sponge. Right. Now, same sponge, but now what I'm going to do is take that sponge, I'm going to hold it at an angle. So when I'm holding the sponge at an angle, that would be like the land if it was hilly, all right? So same amount of water, pour it on the sponge, and you're seeing that a lot more of the water is running off because it's harder for the water to soak into the ground when the ground's at an angle, all right? It's easier for the water to infiltrate when it's flat. It's harder for the water to infiltrate when it's at an angle, so more of the water runs off. So hilly areas get more runoff than flat areas do, typically. All right, runoff occurs when 4, the ground is frozen. Now, I actually could demonstrate it with that sponge again if I took the sponge and got it wet and then put it outside in the cold temperatures for a while, but I didn't do that, so I'll just have to take my word for it. Yeah, so when the ground's frozen, any water that's in the ground is solid. If you try to pour liquid water through it, the waters can't soak into the ground. So as a result, you get lots of runoff. It's especially true in springtime, where maybe like in the course of February, maybe the ground's frozen, maybe a foot thick or so, and then there's a little bit of a warm spell. Maybe the top inch or so thaws out, a lot of snow and stuff melts, but if it's frozen underneath that, the water's not going to be able to soak in the ground, and you get lots and lots of runoff as a result of that. So if the ground's frozen, you typically get more runoff. Now, where does this water end up going? It runs off. Where does it go? Usually ends up going into streams, and the more runoff there is, typically the more stream discharge there is. So what stream discharge is the amount of water that passes by a point over a given time. So that might be like how many cubic feet per second of water is going through a stream, or maybe how many cubic meters of water per minute is going through a stream, or how many gallons or how many liters of water is going through a stream per minute, something like that. That'd be a way of describing the stream discharge. Now, there's a lot of streams and rivers and so forth across the United States that the United States Geological Survey actually sets up gauging stations where it measures the speed of the water and how deep it is and stuff like that. And from that, it can tell how much water is flowing through there. And you could check online. In Phelps, New York, there is a gauging station on Flint Creek. And you could go online, type USGS Flint Creek, and you can see exactly how much water is flowing through the stream right now and what it's done in the past month and so forth. Now, where that water comes from? Well, during like the wet season, like in the spring and so forth, where most of that water is coming from is from runoff. That could be runoff from rain, or it could be runoff from melted snow, but most of the water in there is from runoff, with only a small amount coming from the ground. Now, some streams though, let's say it's in the summertime and it hasn't rained in like 3 weeks. Some streams will dry up completely. All right? Other streams will still have water in them. But if it hasn't rained for like 3 weeks, that water in the stream probably did not come from runoff. So where is that water coming from? Well, in most cases, it's coming from groundwater. So that could be like the stream might be fed from a spring, or it might just be water kind of seeping into the channel. If the stream channel cuts down into the water table, it'd be water kind of going in from the ground into the stream. But in the dry season, if you haven't had rain for a while and there's water in the stream, it's most likely coming from groundwater. Now, let's say there's a rainstorm, and let's say there's a rainstorm, and let's say it's a rainstorm, and this is not a picture of a tree. It's supposed to be a picture of a bunch of tributaries, a bunch of streams coming together to make a larger stream. So let's say here's a bunch of little smaller streams coming together to make a bigger stream. Okay? And let's say that there's a rainstorm came and it came by and it dumped a bunch of rain on that area. Let's say it rained from like 12 to 1. All right? So like during the rainstorm, you know, like 12 o'clock or 12:30 or whatever. So let's say there's a little dude right there just living on that river right there. You know, he might notice the water go up a little bit, but during the rain, he's probably not going to notice the water going up too much. All right. Now, maybe the rainstorm goes from 12 to 1. You know, 1 o'clock, skies clear up, become blue. Then maybe like at 3 or 4 o'clock, what will happen is this guy will start to see the level of the stream get higher and higher, despite the fact it's not raining anymore. All right? Well, what happens is, you know, most of the water that's flowing through the stream at that point is not from the rain that's falling on that spot right there. Most of the water flowing through the stream at that point is from the rain falling up here. But when the rain hits the ground, it's going to take a little while for that water to flow across the surface to get to the stream, and then it's going to flow in the stream, and the stream channels merge together and so forth. And it takes a while for that water to get down to this point here. Right? Now, how long? Well, it depends on how big of a system you have here. You know, if this is just you know, some streams that are, you know, maybe, you know, within 5 miles or something of each other. You know, then it might take a few hours, all right? If you're talking, this is like the Mississippi River, and that's like New Orleans, and this is like, you know, the states up of like Minnesota and way up at the very beginning part of the Mississippi River, then the amount of time it takes to go from there to there might be a number of days or even going in over a week. But the point is that the maximum stream flow, when the stream's going to reach its highest point, or when it's going to crest, is going to happen long after the rain happens, because it takes a while for that water to get down to that point there. All right, next. Vegetation slows runoff, increases infiltration. Let's say that I have a stream channel like this. And one side of it has a bunch of trees on it. And this side here got buildings and cars and all sorts of stuff. Rainstorm comes by, dumps rain on both sides of that. What's going to happen on one side is going to be a lot different from what happens on the other side. Now, on the side that's mostly trees, when it rains, the water hits the tree branches, which just slows the water, and then it falls to the ground. It's going to hit the tree leaves and stuff and dirt and stuff on the ground. As it tries to flow across, it's going to bump into the trees and branches and all sorts of stuff like that. But the point is, the water's getting slowed down quite a bit. And when the water's getting slowed down, that's going to give more of the water a chance to soak into the ground. So if there's a lot of vegetation, I get more infiltration, and then I don't get as much as going to run off. All right? That's what happens if an area still has lots of vegetation. But let's go to the other side of the stream where it's been developed. So the trees have been cut down, they've put a bunch of buildings there, maybe put roads and parking lots, blacktop and concrete and all sorts of things like that. Well, in that case, when it rains, the water can't go through a building, the water can't go through concrete, the water can't go through blacktop. So if it can't soak into the ground there, what's going to have happen is most of that water is going to run off with only a smaller amount soaking into the ground. So the more a place has been urbanized, the more a place is developed, that's going to result in a lot more runoff than an area that's forested. And this is going to be potentially dangerous because the more runoff you have, the more susceptible you are to flash floods. So the water is going to work its way to the creek much faster, which will make the creek's level go up higher, faster than it would in this situation. Here, the water would more gradually be released in the stream, which would mean that it wouldn't get high, it wouldn't get as high, and the height of it would get stretched out over a longer amount of time. So this is going to be a lot more dangerous to the stream than this would. So vegetation slows the runoff and allows more infiltration to happen. If it's mostly blacktop and stuff, you're going to get more runoff because the water can't infiltrate the ground. All right, lastly here. All right, so here's like a cross section of a stream. All right, there's the level of the water right there. Let's say there was some rain and the level of the water went up to that level right there. All right, that would not be a flood because the water's staying inside this channel. All right, it's not going to be a flood until the stream overflows its channel. Now, quite often on either side of the stream, the banks are going to be a little bit higher. Those are called levees. All right. Now, as long as the water stays in a channel, it's not flooding. But if the water gets higher, then overflows the levees, what's going to happen is it's going to flood the area like that. Now, this flat area over here on the sides of the stream that are going to get flooded when the river or stream overflows the banks, overflows the levee there, that's what's referred to as the floodplain. All right, that's the floodplain. Now, floodplains, a lot of times they make really good farmland. And the reason being is whenever this floods, it's going to bring lots of new nutrients to the ground there. So it makes good farmland. But what a lot of people have done is a lot of people have also built houses and stuff or cities in the floodplain. And the reason being is they like being close to the water. All right. All right, they like being close to the water. Get the drinking water. The water could be used for transportation, for shipping things, and flat land's easier to build on than hilly land. So a lot of cities and stuff are built in these areas that are floodplains. All right, so obviously they don't want the city to flood. So what they do is they make they'll build artificial levees. So they'll make the size of the stream higher like that. All right. So now, if the level of the water here gets high, let's say the level of the water here got this high, it won't flood this way, it'll flood over there. All right. So that artificial levee will protect the city here from all that water that would have gone over there. Now you're sending it over there. All right. Well, I mean, you're not like making water disappear. You're just putting it from one place and moving it to another. So whereas before, the flooding here might have been 3 feet deep, now that you've blocked off half the valley, so this water can't go that way anymore. Maybe when it floods, it gets 6 feet deep over here. So over here is more of a problem now because more of the water is going over there. Right? So we're like, well, maybe these guys don't want their land flooded anymore. So what they do is they build a high levee of their own on that side. All right. So now that side won't flood. All right. Well, the thing is, the water doesn't just disappear. The water's got to go someplace. So the higher levees you build on both sides of that, all it's doing is you're sending this water downstream, and you're making your problem someone else's problem. Now they got to deal with it. So when you build all these levees like that, you're really just shifting the problem around. You're not solving any problems. All right. Now, let's say you lived in a low-lying area and you're watching TV, and all of a sudden you start to see the National Weather Service has issued a flood warning for low-lying areas next to so-and-so and so-and-so. The safety tip, if you're in a low-lying area and there's flood warnings, a lot of times flash flood warnings are the ones you worry about, like after a thunderstorm. The safety tip is you head to high ground, all right? So like if these guys had a flood warning right there, they'd want to go up there, higher up, away from the water. So safety tip for floods is head to high ground, all right? That tip may save your life someday. All right.